take a look at the last section that we're going to do in chapter 5. Okay, so we're just covering 3 sections in this chapter. And this is all about the hinge theorem. So this is really similar to the other ideas that we've talked about already in this chapter. Okay, the hinge theorem just says that if we have 2 sides of one triangle congruent to 2 sides of another, and then we look at the angle that's between them, okay, whichever angle is greater, the side opposite that angle will be greater. Right, so it's similar to the idea that we've already talked about. Right? So, and it's called hinge theorem because we already mentioned a couple of days ago, it's like a door. Right? If I say, well, I've got one triangle where I've got the door as the side and then the frame as the other side, I open it just a little bit, I've got a small angle there. So the side opposite that, the opening of the door is very small. But if I open the door a lot more, okay, with the same length of the door and the same length of the frame, well, the angle is much larger, therefore the opening of the door is much larger. Right? That would be the side of the triangle opposite the larger angle. Then we can just say the same thing in reverse for the converse of the hinge theorem. If we have 2 congruent sides, and then we know the third side length, whichever side length is longer tells me the larger angle. So in this case, angle M would be larger than angle R because it is opposite a longer side. Okay? So, the first few questions on this note sheet are just about comparing sides and angles. So if I look at these 2 examples here, first one just says compare the measures of GF and FE. Okay, well, since GF is opposite a larger angle, and this only works because I know that HG and HE are congruent, and then we also know that HF is congruent to itself, right? So the only reason this works is because I know that these 2 sides are congruent to these 2 sides. Then if I have a larger angle, I know for sure that GF will be greater than FE. We can do the same thing given a third side length here. Okay, so again, this only works because I know that BC and BA are congruent, and then I also know that BD is congruent to itself. So I have a pair of congruent sides. Then if I know the lengths of the third side here, I can say that this angle is larger than this angle because it's opposite a larger side. So I can say that the measure of angle ABD is greater than the measure of angle CBD. Okay? We don't know what the actual measures are. We just know for sure that this one will be larger than this one. Okay? Questions? Is that hard to see? My black one is running out here.
We're just saying either the side or the angle is bigger.
For this first part, yes. But these first few exercises are this idea. Then we'll talk about the second part here in a minute. Alright, so let's take a second and try these 4 problems here. See if we can figure out which side or which angle is greater from the given information. mean, there'll be something you have to identify what it is. Well, like it is in
Whoa.
Did we get these inequalities here? For 1, MR is greater than RP. For 2, AD is greater than CD. For 3, measure of angle C is less than the measure of angle Z. Okay, I mean, you could always write these the other way and say measure of angle Z is greater than the measure of angle C. And the last one, measure of angle XYW is less than the measure of angle XYZ. Questions so far? All right, then let's throw in a little bit of algebra. So for the ones on the back here, we want to use the same idea. We want to look at the given information. So on this one, what I have is that these two sides are the same. And then I know that they share a side, so obviously that side is congruent to itself. So using the hinge theorem, I can look at the angles in between those two sides. If this angle is 120 and this angle is 115, that tells me that this side is going to be longer than this side. So I can set up an inequality saying that 4x minus 10 has to be greater than 40. Okay. Since we know this angle is larger than this one, this side would have to be longer than this side. So now, I just want to get x by itself in this inequality. So, I'm going to add 10. 4x then is greater than 50. Divide by 4. We get x is greater than 12.5. Okay. So we solve inequalities the exact same way that we do equations. Remember, the only thing that we could run into that might be different is if we divide by a negative number, we flip the sign. Right? So, I mean, it might be good to make a little note of that, even though it doesn't show up on this problem. The only difference between solving an inequality and solving an equation is when you multiply or divide by a negative number. Flip the inequality. Questions on that idea? All right, why don't you guys try number 6 then?
Are we going to do number 7?
Yeah, we're going to do number 7. Yeah, I mean, you can go ahead and try it if you would like. Make sure you draw a picture for it.
Ooh.
Did we get x has to be less than 12?
Yeah.
All right, so, I mean, the only potential tricky part is which way to put your inequality sign. And that just comes from the hinge theorem that we're talking about. In this case, the 3x minus 3 is opposite a smaller side than 33 degrees. So we would say it has to be less than 33. All right? Do you guys want to try the story problem here, or do you want to go through it together? I heard a lot of try it, so I'll give you guys a minute to try it here, and I'll come around and help, but then we can go through it together here in a couple of minutes. Okay. Draw a picture. Drawing a picture here is going to be the best way to go about this. So we're saying Team A goes 7.5 miles due west. So when it says
north of west. North of west, south of west. Okay. Does that make sense?
No, you
You do understand if there's a greater angle, the side has to be bigger. Therefore, their distance must be greater.
Okay, we'll see. We'll see.
So, yeah. So when we're saying 35 degrees, so this is due west, and then if we go 35 degrees north of west, this is the angle that would be 35 degrees north of west. And then they could turn and go 35 degrees north.
I see to go back in.
Why? It's not even right because they wouldn't go and then go back and then go up.
Well, they should be going up.
So, yeah, so this is west, this is north. So northwest would be going in this direction.
West.
This
Three
is
to the left.
145 here.
Okay, and then they go
Because they don't go out
So,
and
yeah,
come back in.
We're going
That makes sense.
directly west,
Honestly,
and then they turn and go northwest.
Oh,
obviously.
What? I'm telling you that mine makes sense. Not yours.
All right, so this is the situation that's occurring here, right? The first team goes 7.5 miles due west, then turns 35 degrees north of west. So that 35 degrees is actually this exterior angle, okay? If we're going 35 degrees north of west, we're turning this way. So this direction is northwest. If the 35 degree angle were on the inside, that would mean they turned and went this way. That direction would be northeast, right, if we're going this way. So 35 degrees north of west means we're turning that much right there, going 5 miles. So they end up over here. Same reasoning over here. So the second team goes 7.5 miles due east, then turns 40 degrees north of east and goes 5 miles. So the angles on the inside of these triangles, this one would be 140, right, because those are a linear pair, and then this one would be 145. So now, using the hinge theorem, we can say that this distance will have to be larger than this distance. So if this was team A, right, and this was team B.
So hinge theorem.
We could have explained something.
No, you said you were right.
Yeah, so hinge theorem just says if I have two sides the same in two triangles, so like this one's 7.5 and 5,
Okay.
7.5 and 5, then if I look at the angle in between those two sides, that's going to tell me which of the opposite sides is greater. So in this case, this angle is larger, that means this side is greater than this side. Okay, so our answer would be team A is farther from the base camp. And then how could we justify that? It says explain your reasoning. What could we say to justify that? Yeah, so, I mean, we'll end up saying, by the hinge theorem here. So we could say team A is farther from the base camp because because team A turns at technically they're turning at less of an angle ends up making the angle on the inside of the triangle greater. So let's say it turns at less of an angle than team B. Creating a larger angle on the inside of the triangle. Questions on the hinge theorem, or the converse of the hinge theorem?
Sorry, but like, can you explain five?
Yeah, I'll come help you with those. No other questions?